When connecting multiple number 6 copper conductors to ground rods, several methods can be used depending on the situation and applicable electrical codes. It's essential to consult with a qualified electrician or review the relevant codes before performing any electrical work. Here are a few options for connecting multiple grounding conductors. Firstly, individual connections may be implemented. Each number 6 copper conductor is connected to a separate ground rod. This approach offers a secure and reliable grounding path for each conductor. To establish these connections, utilize a ground rod clamp or another approved method to firmly attach the conductor to the rod. Ensure the clamp is appropriately sized for the conductor and rod, and that it is made of a material compatible with both to prevent corrosion. Tighten the clamp securely to ensure low resistance connection. Secondly, you could use a common connection. All number 6 copper conductors are connected to a single ground rod using a grounding lug or another approved method. While less secure than individual connections, this method can be suitable when space constraints exist or multiple ground rods cannot be installed. When using a grounding lug, make sure it is appropriately sized for the number of conductors it will accommodate. Crimp or tighten the lug according to the manufacturer's instructions and ensure it is securely attached to the ground rod. Thirdly, there is the option of a jumper connection. Connect one number 6 copper conductor to one ground rod and then run a jumper conductor from that rod to the other rods. This approach balances security and reliability while minimizing the amount of conductor needed. The jumper conductor should be the same size as the main grounding conductors, which is number 6 copper in this instance, and connected to each ground rod using appropriate clamps or lugs. This method effectively creates a network of interconnected ground rods, ensuring a solid grounding path. Fourthly, a busbar connection may be used. A grounding busbar can be installed in a convenient location, and then the number 6 copper conductors connected to the busbar using grounding lugs or other approved methods. This is common in larger electrical installations with multiple grounding conductors. The busbar should be made of a conductive material like copper or aluminum, and sized appropriately to handle the anticipated fault current. Mount the busbar securely and ensure all connections are tight and corrosion resistant. When selecting a connection method, consider several factors. The type of soil is important. Soil resistivity impacts the effectiveness of the grounding system. High resistivity soil requires more extensive grounding systems, potentially involving multiple ground rods or chemical treatment to reduce resistance. The local electrical codes and regulations are also important. Adherence to local codes is mandatory. These codes specify the required grounding methods, conductor sizes, and installation practices. Familiarize yourself with these requirements before commencing any work. The size and type of electrical system should be considered. Larger or more complex electrical systems may necessitate more robust grounding systems. The size of the service entrance, the number of branch circuits, and the presence of sensitive electronic equipment all influence the grounding requirements. The available space is another thing to consider. Limited space may restrict the choice of grounding methods. In confined areas, alternatives like chemical ground rods or ground plates may be necessary to achieve adequate grounding. It's also important to use approved materials and methods. Only use grounding clamps, lugs, and conductors that are listed and labeled for grounding purposes. Follow the manufacturer's instructions for installation to ensure a safe and effective grounding system. Here are some additional best practices for ground rod installation. Select the appropriate ground rod. Ground rods are typically made of copper-clad steel or stainless steel. Copper-clad steel rods are commonly used due to their good conductivity and corrosion resistance. Stainless steel rods are preferred in highly corrosive environments. Choose a rod that is long enough to reach moist soil. Typically, a length of 8 feet is required, but local codes may specify a longer length. Drive the ground rod into the earth. Use a ground rod driver or hammer to drive the rod vertically into the ground. Ensure the rod is driven deep enough to comply with local codes, typically until only a few inches remain above ground. If rocky soil prevents vertical installation, the rod can be buried at an angle not exceeding 45 degrees from vertical, or even horizontally, at a depth of at least 30 inches. Ensure proper bonding. Bond the ground rod to the electrical system's grounding electrode system. This involves connecting the ground rod to the main grounding busbar or neutral busbar in the service panel using a grounding electrode conductor. The size of this conductor is determined by the size of the service entrance conductors, as specified in the National Electrical Code, or NEC. Inspect and test the grounding system regularly. Periodically inspect the grounding connections for corrosion or damage. Test the ground resistance using a ground resistance meter to ensure it remains within acceptable limits, typically 25 ohms or less. If the resistance exceeds this value, additional ground rods may be required. Grounding systems are essential for electrical safety. A properly installed grounding system protects against electrical shock, minimizes the risk of fire, and provides a path for fault current to return to the source. Grounding ensures that metallic parts of electrical equipment and systems are at or near ground potential. This reduces the risk of electric shock if someone comes into contact with a live conductor. In the event of a fault, such as a short circuit, the grounding system provides a low impedance path for fault current to flow back to the source. This high current triggers the circuit breaker or fuse to trip, quickly disconnecting the power and preventing further damage or fire. Grounding also helps stabilize voltage. By providing a reference point at ground potential, the grounding system helps maintain a stable voltage level within the electrical system. This prevents voltage fluctuations that can damage sensitive electronic equipment. Grounding is a critical component of electrical safety and should never be overlooked. Always consult with a qualified electrician to ensure the grounding system is properly designed and installed in accordance with local codes. Remember, electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and working with the energized circuits whenever possible. If you are not comfortable working with electricity, always hire a qualified electrician to do the job. In summary, when connecting multiple number 6 copper grounding conductors to ground rods, the appropriate method depends on the specific circumstances and applicable electrical codes. Individual connections offer the most secure grounding path, while common connections are suitable for space-constrained situations. Jumper connections balance security and conductor usage, and busbar connections are common in larger installations. Always consult with a qualified electrician and adhere to local codes to ensure a safe and effective grounding system. Regular inspection and testing are essential to maintain the integrity of the grounding system. Electrical safety is paramount, and proper grounding is a critical component of protecting against electrical shock and fire hazards. Always prioritize safety and seek professional assistance when necessary. The NEC provides detailed requirements for grounding and bonding electrical systems. These requirements are designed to ensure electrical safety and prevent hazards. Some key sections of the NEC related to grounding include Article 250, which covers grounding and bonding in general, and Article 300.5, which addresses underground installations. Article 250 provides requirements for grounding electrode systems, grounding conductors, and bonding conductors. It specifies the types of grounding electrodes that are permitted, such as ground rods, ground plates, and metal water pipes. It also outlines the requirements for sizing grounding conductors and bonding conductors based on the size of the service entrance conductors. Article 300.5 covers the installation of underground electrical cables and raceways. It specifies the minimum burial depths for different types of cables and raceways, as well as the requirements for protecting underground cables from damage. In addition to the NEC, local codes and regulations may also apply to grounding and bonding electrical systems. These local codes may be more stringent than the NEC in some cases, so it is important to be familiar with the local requirements before performing any electrical work. When installing a grounding system, it is important to follow the manufacturer's instructions for all components. This includes ground rods, clamps, lugs, and conductors. Failure to follow the manufacturer's instructions can result in a faulty grounding system that does not provide adequate protection. Regular inspection and testing of the grounding system are essential to ensure it is functioning properly. Grounding connections should be inspected for corrosion or damage, and the ground resistance should be tested to ensure it remains within acceptable limit. If the ground resistance is too high, additional ground rods may be required to improve the grounding system. Grounding is a critical aspect of electrical safety, and it is important to take it seriously. A properly installed and maintained grounding system can protect against electrical shock, prevent fires, and ensure the safe operation of electrical equipment. Always consult with a qualified electrician to ensure the grounding system is properly designed and installed in accordance with all applicable codes and regulations. Furthermore, consider the specific application when selecting grounding methods. For instance, in sensitive electronic environments, a dedicated equipment grounding conductor may be necessary to minimize electrical noise and ensure proper equipment operation. This conductor provides a low impedance path for fault current to return to the source, reducing the risk of voltage fluctuations and interference. In industrial settings with heavy machinery, a robust grounding system is essential to protect against electrical hazards. This may involve the use of multiple ground rods, grounding grids, and equipotential bonding to ensure that all metallic parts of equipment are at the same potential. Equipotential bonding involves connecting all metallic parts of equipment together to create a common ground potential. This prevents voltage differences from developing between different parts of the equipment, reducing the risk of electric shock. In addition to grounding, bonding is another important aspect of electrical safety. Bonding involves connecting all metallic parts of an electrical system together to create a continuous electrical path. This path provides a lower impedance route for fault current to flow back to the source, helping to trip the circuit breaker or fuse and disconnect the power. Bonding also helps to minimize voltage differences between different parts of the electrical system, reducing the risk of electric shock. The NEC provides detailed requirements for bonding electrical systems. These requirements specify the types of bonding conductors that are permitted, as well as the methods for connecting bonding conductors to different parts of the electrical system. When installing bonding conductors, it is important to ensure that all connections are tight and corrosion resistant. Loose or corroded connections can increase the impedance of the bonding path, reducing its effectiveness. Regular inspection and maintenance of bonding connections are essential to ensure they remain in good condition. In summary, grounding and bonding are critical aspects of electrical safety. A properly installed and maintained grounding and bonding system can protect against electrical shock, prevent fires, and ensure the safe operation of electrical equipment. Always consult with a qualified electrician to ensure the grounding and bonding system is properly designed and installed in accordance with all applicable codes and regulations. Remember to consider the specific application when selecting grounding and bonding methods, and to inspect and maintain the system regularly to ensure it remains in good condition. Proper grounding and bonding are essential for electrical safety and should never be overlooked. When connecting multiple number 6 copper conductors to ground rods, remember that proper techniques, adherence to codes, and regular maintenance are key to ensuring a safe and effective electrical system. Consider individual connections for secure grounding, common connections when space is limited, jumper connections for balance, or busbar connections for larger installations. Always prioritize safety and seek professional guidance when needed.